Yes, good evening. Good evening. Welcome to this day. We are going to current. And our main objective today is to understand and explain the basic electrical quantities and their SI units. Now, I hope everybody is in class and those people who have not even joined will join as we proceed. The quorum is there. Now, before we start, we are going to observe the online rules to ensure you mute your microphone to just to avoid the interference. Okay, for today's lesson, we are going to start with the current as one of the basic electrical quantities. As you can see, the current we have derived it from the our topic today, which is the DC current. Now, maybe I'll start by asking one of you to explain the meaning of the current. What is current? Yes. Come again? The flow of electric charge. Do you have anybody with a different opinion? Yes, current flow of electric. Yes, I think those are correct answers, and I've shared a slide there. Maybe we'll move together and we understand the meaning of the word current. Now, the current is the flow of electrons. From the explanation you can read, it says that 1 ampere is a flow of electric charge. Now, the current, we are saying that current is the flow of electrons. Now, we need to understand what is electrons. What is electrons? Could anybody having an idea of what is an electron? It is true that we say that current is the flow of those charged particle, which is the electron. But what is electron? Yes, good. If you flash back on your Form 4 physics, we learned about moles. Moles, we said that the construction of moles, the inner part of the moles is made of protons and protons, and it is surrounded by an orbit which has a moving electrons. Those moving electrons is the one which is now considered as current. So current is the rate of those movement of electrons. I think you are together there. Yes. The movement of electrons from one area to the others through a conductor. Now, for that movement to take place, we need a force that is going to be applied to make sure that those things moves in one direction. That's why we say when the electrons move in one direction, now DC, the direct current comes in. When you talk of the alternating current, is the one which moves ups and down. They don't move in one direction like water. So that force that forces that particles, the charged particle to move, is what we call the voltage. So voltage is our second basic electrical quantity. Now, what is the SI unit for current? Somebody, the SI unit for current? I. I stands for what? Amperes. Very good. Amperes. So when you say that a fuse is rated at 1 amperes, it means what? It is one charged particle per 1 second. The movement of one charged particle per second. So that's when you say that the fuse is rated at 1 amperes. When you say it is 2 amperes, it is two charged particle which is noted by coulombs per second. So that's why we are saying current is the rate of charged particle from one place to the other. Now, what is the SI unit for voltage? SI unit for voltage, button, you are saying? Volts. Yes, the SI unit for volts are for for voltage is V. And you have said what is voltage, Mr. Mirao. You have said what is voltage. Yes. Yeah, that's a very good answer. Voltage is the potential difference between 2 points. And if you can use an analogy of water, a water tank which is raised up, that water tank, the water itself which is in the tank is related, you can use it as a current in relation to the electric. And that force that forces that water to move out is the one which are calling as voltage. So the potential difference between that water up there, the tank, and the downstream is those potential difference we're talking about. So the voltage, the definition of voltage is the potential difference between two two points of a conductor, and it is noted by a volt. Now, you have said that current is the movement of charged particle from one place to the other. So we expect when the particle moves through a conductor, it experiences some opposing forces. That opposing forces gives us the third quantity of electricity. Now, what is that? The third quantity that we are talking about. Which one is that? That opposes the movement of the charged particle, resistance. So, as we have said, resistance is the opposing opposing forces that opposes the movement of particles in any conductor. That's why we say the copper is a good conductor because it has less opposing factors compared to those other conductors. Now, we also have some other quantities like wattage and electromotive force, but the main three ones, is the voltage, the current, and the resistance. And in summary, we said that current is the movement of that particle from one place to the other. You have also said that the SI unit for that current is amperes. We again said that the voltage is the potential difference between two points in a conductor, and the SI unit for that is the voltage. And the final one, the main one, is the resistance, which is the opposing factor or the opposing uh, the measures that opposes that movement of those charged particles. Now, we also have the electromotive force, which normally goes together. And in our previous, when we started, I said that the mole is made up of, I said it's made up of what? The mole or the atoms. You know, all the conductors are made of atoms. So those atoms, the nuclear part of it, it's made up of, he said it's made up of what? Mark, exactly. Neutrons and protons. And those are the one which determines the charges of that particular atom. If the number of protons is more than the number of neutrons, we say that atom is positively charged, and vice versa. If the number of protons is more than the number of protons, we say it is negatively charged. So when those atoms moves along the conductor, it's either negatively charged or positively charged. So those forces, the opposing and the attraction forces, is the one which we call the motive force. And the work happens when those things moves along the conductor is what we call watts, the wattage. I think with those few, we have come to the end of our lesson today. And maybe I'll ask you to do as an assignment. You go and discuss on the simple calculation of the voltage, the current, and the resistance. That will be our basic for our discussion for the next lesson. Okay, thank you for today's lesson, and I beg to end our lesson for today. Yeah, thank you.